So in this video I'm going to be looking at a part of algebra, and particularly a part of functions, and that is the limits to functions and asymptotes. Now what asymptotes are lines that our curve cannot cross. So I have a horizontal asymptote here, and it is a line that my curve cannot cross. You need to remember, so I can see my two blue curves, they get really close to the asymptote. You can see they get really close sort of here and here, but they never actually cross the asymptote. So even if they go to infinity over here, it gets infinitely close to the asymptote, or infinity over this direction, it gets infinitely close to the horizontal asymptote, but never reaches it. Now remember, what do we know about horizontal lines? We know the equation of all horizontal lines are y is equal to something. So to find the horizontal asymptote, you set the limit as x goes to infinity of the function, and you will get y is equal to out of that. So horizontal asymptotes, set the limit as as x goes to infinity. To get the vertical asymptote, well, think vertical asymptote, we can see again here the curve gets infinitely close to this blue or purple line here, and again up here it gets infinitely close but never actually crosses it. To get the vertical asymptote, you need to consider, well, what's the equation of a vertical line? Equation of vertical lines, well, what could this point be? This could be minus 1, 1, 2, 3, 4, 5, 6, 6. This could be minus 1, 8. This could be minus 1, 3. And so on and so on and so on. All of them are x is equal to. So vertical asymptotes are x is equal to. The way I like to think of it as, the curve can never cross this vertical asymptote. So vertical asymptotes are a line the curve never crosses. So we find the value that x can never be. Generally with these, you're given an algebraic equation, or function, an algebraic function that has a fraction in it. So you find when will the fraction have 0 on the bottom line. So again, in exam questions, you're generally given an algebraic fraction, so to find the vertical asymptote, set the bottom line equals to 0. And what you're doing here, setting the bottom line equals to 0, is finding the value that x can never be. Because we know we can't have 0 on the bottom line, because the world would explode if we had 0 on the bottom line. So I'll show you what I mean by that. So if I were to take this function here, this f of x, doesn't look like an f of x is equal to 6x minus 3 over x plus 2, or 2 plus x. And I want to find the vertical asymptote. I take the bottom line and set it equals to 0. And then I would find x minus 2 is the vertical asymptote. If I want to find the horizontal asymptote, I would say the limit as x goes to infinity of 6x minus 3 over 2 plus x. Now how to deal with limits then? So the first thing you check is, can I actually sub in infinity? Well, 6 times infinity would be infinity minus 3. So infinity minus 3 would still be infinity. 2 plus infinity would be infinity. Now if I ever get infinity over infinity, it's called indeterminate. Other examples of indeterminate would be 0 over 0, or what could you say? 0 over 0, or Well, anything over 0, because we can't divide by 0. They're all indeterminate. So if it's indeterminate, there must be some form of simplification I can do. Well, there's no factorizing out of the top line and the bottom line that I can do to simplify it. So the other idea that I could do would be to multiply top and bottom by 1 over the highest power of x. Now, why am I allowed to do that? Is because 1 over x over 1 over x is 1. And what I do then is 6x by 1 over x is 6, minus 3 by 1 over x is 3 over x. 2 over x plus x over x, which would just be 1. 3 over x. And now I applied the limit. So I go limit as x goes to infinity of 6 minus 3 over infinity, 2 over infinity plus 1. And now we run into an idea, or a situation, I'll put that there. Now I can remove the limit. Actually, I'd keep the limit. Limit as x goes to infinity, x, and in the next line I apply the limit. So 6 minus 3 over infinity, 2 over infinity plus 1. 6 is going to remain there. 3 divided by infinity. Well, 3 divided by 1 is 3. 3 divided by 2 is 1.5. 3 divided by 3 is 1. 3 divided by 4 is 3/4. 3 divided by 10 is 0.3. 3 divided by 100 is 0.03. 3 divided by 1,000 is 0.003. 3 divided by a million is 0.000003. 3 divided by a billion is 0.00000003. So the bigger the denominator gets, the smaller the number gets in general. So this is actually going to go to 0, and same as this is going to go to 0. So 6 minus 0 is 6, 0 plus 1 is 1, and you'd just be left with 6. So now this is your vertical asymptote. Y is equals to 6. Follow on question from it. They might ask you to sketch the graph, a rough sketch of the graph, or the possibilities of the graph. So, not even the graph, they might just say the asymptotes. So what you would look like would be going, grand, xy axis, I know y is equals to 6 is the vertical or horizontal asymptote, excuse me. Just need the pen here. Y is equals to 6. 1, 2, 3, 4, 5, 6. And the vertical one was x is equal to minus 2. Minus 1, minus 2. So either the curve is in here, if it's always increasing, and you can find if it's always increasing by differentiating and seeing is it always positive or negative, or it's in here if it's always decreasing. So again, differentiate it and see is the dy dx negative. To follow on then from what I was talking about, more examples of evaluating limits. Let's see this one. If you applied the limit, let's see what you'd get. You'd get 5 squared, so x is going to 5, not infinity, over 25, over 5 minus 5 is equal to 0 over 0. And the phrase that I used for that is indeterminate. So there's either some form of simplification that I can do, or I can multiply top and bottom by 1 over the highest power. So I'd be going 1 over x squared, 1 over x squared, and then applying the limit. But you might actually spot that there is some form of simplification that I can do, because that top line is the difference of 2 squares. So it's x squared minus 5 squared over x minus 5. So that's the limit as x goes to 5 of x minus 5, x plus 5 over x minus 5. And then limit, as x goes to 5 is x plus 5, because the x minus 5 and x minus 5 cancel. So now I can set my limit of 5. So I'm getting 5 plus 5 is equal to 10, and that's the limit right there. Now what that means is if you look at this over here and go, well, limit as x goes to 5 of x minus 25 over x minus 5. Let's try x is 0, x is 1, x is 2, x is 3, x is 4. That's a 5, not a 4. 4. I'm going to use my calculator to find those really quickly by just using the table function, but you don't really need to know them. Well, the first one would be minus 25 over 5, which would be 5. The next one would be 6. The next one would be 7, 8, and then 9. You can see as x is getting closer and closer and closer to 5, the value of the output is getting closer and closer and closer to being 10. That's what it means by the limit. What is the output getting closer and closer and closer to being? So some of these are very easy if you were to consider as x goes to infinity. Well, what would 1 divided by infinity be? Well, if you've one pizza and infinity friends, everybody basically gets 0. Here, this is 4 divided by 3 times infinity. Well, 3 times infinity is infinity, so it's 4 divided by infinity. And again, everyone's getting 0 pizza out of that. This is 1 divided by infinity squared. Again, that's 1 divided by infinity. Infinity squared is just infinity, so you're getting 0 again. And then k, I take it that k is an integer, so a positive or negative whole number including 0. You're again probably going to get 0 out of that. Whereas a scenario, let's say like this, if you apply infinity, you'd get 4 infinity minus 3 over 7 infinity minus 6. That's still infinity over infinity. That's indeterminate. Infinity over infinity is indeterminate. Is there any simplification that I can do by factorizing? No, not really. So again, I multiply top and bottom by 1 over the highest power of x. So it's 1 over x in this case. So I'm getting 4x by 1 over x. Limit as x goes to infinity is 4 minus 3 over infinity, 7 minus 6 over infinity. And I'm going to say x, not infinity. I've, again, subbed in infinity too early. Now I apply the limit. I'm getting 4 minus 3 over infinity, 7 minus 6 over infinity. 3 divided by infinity is 0. 6 divided by infinity is 0. So you're just left with 4 over 7. And that's the answer. And last but not least, this question here. I know I'm going to get, like, look, you can do it in your head. Infinity squared minus infinity plus 2 would be infinity. 6 times infinity squared plus 5 infinity minus 6. You'd get infinity over infinity, which is indeterminate. So there must be some form of simplification I can do. Factorizing's not going to work here. So I'm going to go limit as n goes to infinity, 2n squared minus 3n plus 2 all over 6n squared plus 5n minus 6 times 1 over the highest power of n. So that's 1 over n squared, 1 over n squared. Limit as n goes to infinity. And even if there wasn't a square here on the bottom line, it would still be 1 over n squared, 1 over n squared. It's the highest power of n in the whole question. So you're getting 2 minus 3 over n plus 2 over n squared, because I'm just doing top by top, bottom by bottom on the top line, and then top by top, bottom by bottom again on the bottom line. That should be squared. 6 plus 5 over n minus 6 over n squared. And now you apply the limit. 2 minus 3 over infinity plus 5 over infinity squared. 6 plus 5 over infinity minus 6 over infinity squared is 2 over 6 is what you'd be left with, which is 1 over 3. 3 divided by infinity is 0. 5 divided by infinity squared is 0. 5 divided by infinity is 0, and 6 divided by infinity squared is 0. So again, sometimes you can do it with factorizing. I think here, no, you're not able to factorize it, and you're not able to factorize it. So again, you'd be multiplying by 1 over n squared, 1 over n squared, and again 1 over n squared and 1 over n squared. Hopefully you found this little crash course on asymptotes and limits to be useful.